talk about their new database aware storage capabilities within Tintri VMStore, but we couldn't get that organized in time. So what we're going to do is follow up with that next week on Tuesday. But today, what I'm going to do is give you a bit of an insight into what Tintri are deploying now with their new storage aware, well, database aware storage platform. So let's kick off then and see a little bit about it. So first of all, Tintri have been quite unique in the way that they've deployed storage for virtualized environments for some time, and we've worked with them since they came into the UK. And it's always been about reducing the amount of effort that you need to maintain and manage the infrastructure, but also to give you the best performance. And this has been taken over now into the database side of things. If we look at some of the key things that we're trying to do around this, and what we've got is to think about three different areas. The first is the DBA's perspective, and what the DBA is looking for is, he's got no time and limited skills with the actual infrastructure, the storage components of it. So really wants it to be very limited what he needs to do that. Also, on the database side of things, they don't want slowdowns. They want to have the same level of protection without any impact on the performance of the database when you're doing things like snapshots and those kind of things. Another thing is visibility. It's quite common that the DBAs have very limited visibility of the underlying infrastructure and the performance of the databases. All they can see is the actual structure of the data in itself and access the database itself. And what tends to happen is most storage platforms are over provisioned to ensure there's enough performance, which can be a bit of an issue because you run out of capacity quite quickly because you're over committing the amount of storage that you need for it. And I think the other thing is it needs to be predictable. So they need to understand that when they deploy a new database, that they're going to get the performance they need from it, and also required for the specific type of database, whether that's customer facing, whether it's internal, and the way that the actual data then is presented to the application. Also, they don't want to be waiting around for other staff. They don't want to have to wait around for storage admins to add and manage storage so that they can deploy those databases into production, or even if they're actually putting them into position for test and development type activity. If we look at for the infrastructure admin's perspective, though, a lot of times they don't really have a good understanding of what's happening with their infrastructure, and it makes it difficult for them to do some decisions about what's required, also planning for future deployments, what capacity they've got, and also trying to optimize performance can be a challenge as well. If they've got performance issues, again, this tends to cause things like bottlenecks and hinders the performance of the databases and the applications that are using that. And again, they can cause over provisioning, and with that over provisioning, again, you run out of capacity rather rapidly because you're giving each database too much capacity rather than what it needs. Data protection tends to be a challenge as well, especially for the DevOps side. Trying to keep up with the requirements to protecting data in that space can always be very difficult. And also, a lot of times protection's done at a LUN level rather than at the database level, so it's not very granular in a traditional environment. Also, quality of service, and quality of service comes in two ways. One is, we don't really want to have to do a lot of work to ensure we're getting good quality of service, but also if we've got workloads that may be for test and development work, we don't really want to impact production environments with those databases as well. So having the ability to effectively pull back performance and limit the quality of service for some of those test and dev environments so we don't impact production is a good thing. And finally, from a planning perspective, it's quite difficult to predict, what you're going to need for the future. So having the ability to actually look forward 18 months based on your organic growth, or potentially, model off what you're going to be, maybe 4 times the amount of database you currently have in that period of time, to understand what capacity you're going to get, and also the performance metrics you get from it are a good thing as well from that infrastructure admin's perspective. And then if we look at it from a developer's perspective, The development process can be limited while waiting around for people to provide capacity and infrastructure to be able to develop within. And also, it can also be slowed down by the development cycles by again waiting for things like copies and backups of those. From a DevOps perspective, they want it simple as well. They don't want complexity in the environment. So having one single storage pool that these databases go into makes it much simpler for them. They don't want to be waiting on admin staff to be able to have some capacity to launch new versions of their um, database. To be able to self-service would be a really good idea. And finally, on the development cycles, a lot of times they want to effectively refresh the data within a database or clone a database quickly. And having that ability themselves rather than to wait for admin staff to do that, again, is a positive thing when you're doing especially agile development cycles that most organizations are moving to. So, what is SQL Integrator Storage from a Tintre's perspective? So first is giving a lot more granularity and innovative technology in that space. And it's designed specifically for virtual machines originally, but also taking that Tintre's experience and actually applying some of those real benefits into that SQL Server database piece as well adds greater value. Also, having it integrated directly with the SQL Server, so it's non-intrusive and not having any agents and things to be able to make it work, is a critical thing. Again, it makes it much simpler, the infrastructure, if you don't have to have agents or have any intrusive integration. But also automating the storage management for those databases and ensuring performance is a great thing, especially driving around efficiency, empowering the databases to be able to self-service and deliver a consistent user experience helps in this space again. Also, it runs on a VMstore, which is an all-flash platform. So again, we get benefits of performance from that all-flash capability and also very low latency at high throughput. It's always a benefit for database work. So let's have a look at it from a traditional perspective. If we've got storage in place using a traditional platform, we will have some kind of LUN level protection around that, and each database will be sat inside a particular LUN that has to be managed. But what we're trying to do is look at it from a VM level perspective. And what Tintri has always done is given us the capability to look at things at a VM perspective level, understanding everything around that virtual machine, metrics about its performance, and also using things like machine learning and artificial intelligence to understand the workload's requirements, which is a critical thing. But taking those databases and then moving to that database level and actually giving direct integration against that database at the storage level takes it to another position, and also giving us the ability to isolate performance around the database, not just at the VM level. So a lot more granular control of it, but also giving you granular control over the data protection things which we'll onto it. So let's have a look at some of the things that we'd be looking for. So one is unparalleled visibility. So having the ability to look not only at the virtual machine, but actually each individual database and understand what's happening to it. Also getting insights into whether it's actually on the right platform, if it needs to be moved to a different storage platform, if you've got multiple Tintri units. This gives us a much more granular view of what's happening for the infrastructure. Self-service is a key thing, especially in a DevOps environment, because we don't really want the DevOps team to be held back while they're waiting for the infrastructure team to provide storage capacity, compute capacity. So if the actual DBAs and also the DevOps team can actually provision their own capacity for test and development pieces and then seamlessly migrate that into production, makes life much easier. Also, real-time and predictive analytics make a big difference here. One, in real time, understanding what performance we're getting from those databases, if there's any impact from the network compute and any other resources across the end-to-end piece is really important to understand where we've got bottlenecks, where we're getting delays. But also that predictive analytics, so we can actually look forward, especially with a production environment, to understand what the organic growth looks like and how we're going to use up our storage capacity, and also the performance capacity, as well as the actual physical capacity we're utilizing, helps us look forward around 18 months, so that it's not guesswork when we're looking at our capacity management and planning. Also, predictable performance and quality of service are key to this as well, because we don't really want to guess whether we're going to get decent performance out of a new application when it's deployed. We want to ensure we're going to get the level of performance we need for that particular workload. And with the Tintri environment in a traditional VM workload, it actually calculates what the requirements are for that workload and updates it as the actual workload changes through time. So it's looking at really how much read-write capacity and the amount of latency that's developing, and ensuring that every workload gets the best performance. So this is taking it to another level, looking at it specifically to each individual SQL database and ensure we're getting the best performance out of it. And this is affected sometimes by other workloads. You've heard the term noisy neighbor, where you get another workload is taking too much resources from the storage platform and saps other workloads service. With Tintri, you don't get that, the traditional VM approach, but with the addition of the SQL integration, again, each individual database does not impact any others depending on that they're taking, and it's calculated in real time. But also, that also quality of service is ensuring you're getting that right level of performance. But again, if you want to manually set those, you can actually restrict performance for particular test and development workloads, so you don't impact your production environment. But also at that database level, we want to have much more control and efficiency on it. So we were looking at it per database, looking at insights per database, looking at the analytics of that database growth and throughput activity, looking at data protection, also cloning and recovery at the database level. So we can, instead of protecting at a LUN level like you do in a traditional environment, we can actually snapshot with zero stun a database individually. We can clone that database if it wants to be used for, say, a secondary implementation, or if you want to clone it for dev and test environments. And also you can recover an individual database rather than having to restore the whole of the contents of a LUN. Also, it's fast. It's cost efficient as well for development, because one of the key things is having that ability to instantly create databases, cloning them, replicating them. So you've got that access to some database capacity, and the data resides in that for testing or development work. And that zero impact on the performance of the production environment is key as well. And we don't want to use any space. So that zero space utilization will, from a cloning perspective, because of data dedupe and cloning, saves us lots of space in that place until we start to deviate from the original cloned space. It saves us a lot of capacity when we're actually doing development work. Also, zero disruption when we're doing this data protection. So we don't want to have any disruption to performance, so no stun of any of our workloads when we actually take our snapshots. But we also want to make it policy based, so we can actually specify a particular policy, whether that be hourly, 4 hourly, daily, for our snapshots for each individual database, depending on the priority of that database. Also, we want to be able to recover again at a single level without impact on any of the other infrastructure that's there. Also, offloading any resource intensive activities. We want to be able to ensure that those production databases are getting the most amount of performance they can get, and also during maintenance, we don't affect any of the production workloads. If we look across into efficiency and insights, so one, we're looking at providing the easy storage to operate for a SQL Server database implementation. So we're not creating LUNs, RAID groups and things, and to be able to put those into. We want it to be as autonomous as possible for maintaining the actual storage and the databases that reside in them. So we're reducing the amount of time and effort that's required to actually maintain it. We're also looking at a system that provides visibility across those SQL Server infrastructures and the individual databases within those SQL servers. So we can actually understand exactly what's happening, and also from different levels, from the administrator's perspective, the DBA's perspective, and also from the developer's perspective as well. So they can understand exactly the impact of their code development. We're also looking at the most granular visibility. So not only understanding that database and the storage it consumes, but things around it, such as network latency, CPU, and memory characteristics from the load it's utilized. Again, most insightful database storage information as well, to understand the number of tables, how it's growing from a data perspective, to understand how much read-write activity there is, any latency that's being affected by the actual database itself. But also, we want to be able to make better decisions and actions with those advanced analytics. So what we can do now is understand everything across that stack that's affecting our SQL databases. But also, we want to be able to see it in real time and see some capacity metrics as well, and see those visuals for each database and the database file that we've got on the system. It's also the only system that enables us to plan resources and budget for 18 months. I mentioned earlier that we can actually use predictive analytics to look forward at organic growth, but also to model out increases in the amount of databases, as well as other workloads that we might add onto the structure. And it also take account of the CPU and memory utilization from the compute side, so we can understand performance from that side as well. Also, we're trying to lower the capital expenditure for SQL database storage. And some of the things we get there is, one, it's the only database storage that directly see we don't need to over provision to deliver the right level of performance that's required for the databases. Traditional platforms, commonly you'll over provision by a factor of 2, if not greater, to ensure that we've got the performance characteristics we need for the databases. Also, it's the only platform that gives us that database level isolation, so we can protect it from a performance perspective at that database level, rather than at the SQL server level, or even at the data storage LUN level. It's specific to each individual database, not the LUN or the volume. So quite a lot of changes in what it can deliver. Around quality of service, we're looking for consistent quality of service, but not having to put any effort into doing that. So the system itself, it can isolate the SQL databases for consistent performance. It also can provide self-optimize and auto-tuning for those SQL storage components as well. So no work in tuning it to get the performance, it'll automatically deliver that. But on the data protection side, what we're trying to do is provide instant zero-stun snapshots at the database level, so we can be very granular in what we protect and how we protect it, and also setting different policies depending on what we want to do. It's also that restore level as well. So if we want to restore, we want to restore at the lowest granular level rather than a complete LUN or volume. In this case, we can actually restore a specific database without any performance impact on any of the other database or other workloads on the system. And then finally, we're looking at cost-efficient development. It's the only system that can instantly create clones of individual databases at the database level that can then be used by the DevOps teams to actually continue their development or testing requirements. It's also the only one that can give you a refresh database in a few seconds rather than many hours it takes, which delays the development process. Also, finally, what we're trying to do is giving each developer their own database in a sandbox environment, and can do this in under 60 seconds, protect um, the rest of the production environment from what's happening in the DevOps activity. If we look at traditional environments, we're looking at tens, if not hundreds of LUNs, multiple RAID groups and things that are cutting into that capacity and reducing the amount of effective capacity that can be used. Within a Tintri VMstore, that's not the case. The whole of the capacity there can be used and utilized. There's no RAID groups, there's no storage repository piece. It's just one big chunk of storage that can be used by both VM workloads and also database SQL database workloads as well. So it's one big chunk. It makes it much easier to manage. Some of the key things that came over from what VMstore could do traditionally is this workload isolation and dynamic performance. So the artificial intelligence and machine learning is looking at each of those databases and workloads to ensure that each of them is optimized to give the best performance. It's looking at it in real time, modifying the characteristics all the time to ensure we get the best performance. If we speak to most customers who've worked with Tintri, you'll find that most of them never really touch it. They just leave it to do its work in the background. They find that they don't have any issues around performance for any workloads. And it tends to be the platform most organizations feel comfortable putting any type of workload on without considering the impact it might have on other workloads on there. And there is zero administration time. Some organizations are measuring their monthly activity on administration with Tintri in less than a minute. Very low touch. But that real-time and predictive analytics is a key thing. It helps us in troubleshooting, so understanding where latency or issues are across the whole of the stack, whether it's on the compute, network or storage pieces, and quite quickly delving down into it. It also helps us optimize performance to ensure we're getting the right level for the workload that's required, and also planning the future. Looking forward 18 months and understanding what your current organic growth is being affected by time, but also look at it if you're modeling out different workloads. And this is not just for the SQL database, it could be also looking at things around VDI and other workloads in that period on the same set of infrastructure. Developer velocity is key. We need to ensure that development is agile and moves with the requirements of the business. So having this database level cloning capability for that development process, so you can actually create sandbox databases they can work on in that development and testing environments, but also integrates with those DevOps and CI/CD tools. A part of that process, and automation is critical as well. Also, hands-free operations, especially around things like protecting databases. In a conventional storage, there are many things and decisions that need to be made, to be able to protect it. Within a SQL piece, all it is we want to protect a particular database. We set a schedule, and then that database is protected from then on. We can also then replicate that database to another site if we've got site environments, quite simply as well at the database level. It makes it really much simpler to do. So the key things with this new release of SQL Integrator Storage, it's providing operational efficiency insights, it's delivering better decisions and actions with advanced analytics, and AI ops is becoming a real big thing within organizations that are moving towards digital transformation of their infrastructure. And having this AI ops capability built into it, giving you insights into what needs to be done and how, rather than just telling you there's a problem, makes a big difference. Non-disruptive data protection is critical. We need to be able to protect during the daytime. Gone are the days that we did overnight backups and stores when we needed to. The ability to protect data in real time throughout the day, so we've got very little data loss. So our recovery windows are smaller as well, makes a big difference to an organisation. We're looking to lower CapEx costs, especially for SQL Server databases, by reducing the amount of capacity required, so we're not over provisioning makes a big difference in that. But also that performance, having that consistent performance with the auto quality of service gives us a lot more confidence in the way we deploy, but also guarantees that those applications that are deployed are giving the business what they need. But also that cost-effective development piece is critical as well. So we need to ensure that we're moving quickly in our development. We can refresh databases so we can test with different sets of data as we move forward and ensure that the system is delivering what's required. Thank you very much for your time today. A little bit longer than we normally do. Well, around 26 minutes. We normally do about 15 minutes on a Tintri Tuesday talking about specific areas. But I think really today it's quite important to understand the specifics of this new release and how it will impact organisations. And I think it's a major step forward. Yeah, and these databases can be mounted on the Tintri unit not only via a virtual machine but from a physical workload using a SMB3 mount point on the Tintri. So you can run physical SQL Server workloads with the databases stored on there, or you can run a virtual machine SQL Server with the actual database on VMStore as well. So it gives you a lot of flexibility in the way that you do. Hopefully that's been of use. Like I say, we're going to get one of the production product managers on next Tuesday to talk in more depth and how they've come about it, what the release means, and also talk about some early day adopters of Tintri customers utilising it as well. Thank you very much, and hopefully you've enjoyed today.